The environment should drive electric cars more than gasoline-powered ones in 95% of the world. But electric cars are only sometimes clean. Although electric cars have many benefits, they are more environmentally friendly than they are advertised to be. Let's start with eco-friendly electric cars. The idea of electric cars is a brilliant one for the environment. As shining examples of technological progress, they deserve our attention. Would you like to know how environmentally friendly electric cars are? I love that idea. Are they really greener and better for the environment? In a nutshell, yes, but they will take many years to reach their full green potential. The electric vehicle. Since the first modern electric vehicles, EVs, hit the road in 2000s, critics have questioned their clean label. Skeptics have questioned the manufacturing of EVs, battery power sources, and overall autonomy. In light of all the debate and misinformation around electric vehicles today, the facts behind their efficiency have become somewhat clouded. So how clean are they? Electric cars' clean image is frequently contradicted by the pollution associated with the battery manufacturing process. Battery composition includes rare earth metals, which can contribute to carbon emissions during extraction and manipulation. The country in which batteries are produced and their composition, however, have a far more significant impact on emissions than where batteries are produced, according to a report by the International Council on Clean Transportation (ICTT). According to a comparative study between EVs and internal combustion engine vehicles, ICEVs in China, infrastructure and efficient manufacturing techniques are vital to reducing emissions during production. When Chinese manufacturers fabricate EV batteries, they emit 60% more CO2 than ICEV engine manufacturers. Still, if they adopted American or European manufacturing techniques, their emissions could be reduced by 66%. Consequently, pollution created during battery extraction and production is on par or slightly higher than pollution created during petrol or diesel engine production. The lifetime difference. Throughout their lifetimes, electric and internal combustion vehicles emit radically different levels of emissions, according to the ICTT study. Compared to petrol and diesel-powered cars, EVs produce the bulk of their emissions through manufacturing and energy sourcing due to their lack of combustion and tailpipe emissions. Since 2000, ICEVs have steadily reduced their emissions, but electric vehicles produce almost no running emissions. Furthermore, as EVs become more common and manufacturing becomes more widespread, battery recycling will be more efficient and reduce the need for new materials, decreasing the need for mining and battery production. Throughout their lifetimes, electric vehicles have a more significant impact than combustion engine vehicles. The emissions produced by electric vehicles are significantly lower than those produced by fuel-burning vehicles, regardless of how the electricity is generated. A look at the future of transportation. Electric grids are becoming increasingly dependent on renewable energy and reducing their reliance on fossil fuels. EVs are indeed the vehicle of the future because they emit fewer emissions throughout their lifespan, regardless of the energy source they are powered by. Additionally, car manufacturers are acknowledging that electric cars are less polluting and that producing more of them will help reduce the amount of carbon dioxide emitted. Presently, electric vehicles are significantly less polluting than their combustion engine counterparts. It is likely that the technology will become even more efficient and sustainable as it becomes more mainstream. Through economies of scale, EV manufacturing will benefit from better infrastructure, more efficient manufacturing methods, recycling options, and reduced mining of new materials. As long as renewable energy is deployed and the electricity grid is decarbonized, electric vehicles can greatly reduce greenhouse gas emissions, but they are not a panacea. How green are electric vehicles? Over the course of their lifetime, electric vehicles have a smaller carbon footprint than cars and trucks powered by internal combustion engines. Most of the world's electricity grids are still powered by fossil fuels, and electric vehicles depend on that energy for charging. Additionally, the production of EV batteries remains an energy-intensive process. The total emissions per mile of battery-powered cars are lower than those of comparable vehicles with internal combustion engines. The full benefits of EVs will only be realized once electric sources become renewable, which might take several decades. Emissions from batteries are the highest. For electric vehicles to run, lithium-ion batteries are used. Energy-intensive processes involved in making those batteries, from mining cobalt and lithium to manufacturing in gigafactories and transportation, contribute to the substantial carbon emissions associated with EVs today, experts say. In gigafactories, electric vehicle batteries are produced in large quantities. Emissions from electric vehicles are significantly higher than those from petrol cars. Depending on the country of production, that's between 30 to 40% extra in production emissions, primarily from battery production. According to the Washington Post, those higher production emission numbers are seen as an initial investment that pays off quickly due to the reduced lifetime emissions. 93 gigafactories in China produce lithium-ion batteries compared to only 4 in the US, the Washington Post reported this year. Because fossil fuels were the standard 5 to 10 years ago, old gigafactories in China usually produce batteries powered by fossil fuels. Therefore, EVs built with batteries from existing factories will have high carbon footprints. Among the other considerations around battery production, experts pointed out unethical and environmentally unsustainable mining practices, as well as a complex geopolitical supply chain, where countries prefer to rely on something other than other nations for raw materials like cobalt and lithium, as well as dead batteries. Crabtree believes mining will be the last to be decarbonized among the raw materials needed for battery production. Grid recycling and decarbonization. Currently, very few spent battery cells are recycled. Raw materials for battery production are in limited supply, leaving firms with no choice but to recycle. Experts said that could change over time. EVs will start reaching the end of their lives in the next decade, and most auto companies are already building recycling capacity, he said. Researchers at Cambridge University are working to improve battery technology in order to reduce reliance on scarce raw materials and improve environmental sustainability. He added that more efforts are needed to decarbonize the electricity grid. In spite of this, he pointed out that generating electricity from renewable sources will still emit greenhouse gases since solar panels and wind turbines are produced. We'll look at when the electricity grid will be sufficiently decarbonized for electric vehicles to be of large benefit, Knobloch said. Societal change requires policies. No panacea for combating climate change can be achieved by switching from gasoline-powered cars to electric vehicles. It must be accompanied by societal changes that encourage more public transportation and alternative modes of transportation, such as bicycles and walking. In order to reduce private vehicle usage, ample funding and a well-thought-out policy plan are necessary. To combat climate change and curb oil use, governments and automakers promote electric vehicles worldwide. As of 2035, General Motors will stop selling gasoline-powered cars and light trucks and pivot to battery-powered models. Volvo announced this week that it would introduce an all-electric lineup by 2030. Despite being a more climate-friendly option than conventional vehicles, plug-in vehicles still have their own environmental impacts, depending on how they are charged and manufactured. The following are some of the biggest concerns and what you can do about them. The quality of raw materials can be an issue. Most electric vehicles use lithium-ion cells, which rely on raw materials like cobalt, lithium, and rare earth elements that have been linked to severe environmental and human rights concerns. There have been particular problems with cobalt. During cobalt mining, hazardous tailings and slags are produced that can leach into the environment. Studies have found high levels of exposure to cobalt and other metals in nearby communities. It is also necessary to smelt the metals to extract from their ores. Smelting can release sulfur oxide into the air, harming human health. In addition, 70% of cobalt is mined in the Democratic Republic of Congo, a substantial part of which happens in unregulated artisanal mines where workers, many of whom are children, dig the metal out of the ground using only hand tools, at significant risk to their health and safety, according to human rights groups. A better recycling system would be beneficial. The threat of a pileup of spent batteries looms as older generations of electric vehicles approach their end of life. Lithium-ion batteries are used in most electric vehicles today, which store more energy in the same space as lead-acid batteries. The recycling rate for lithium-ion batteries is estimated at around 5%, compared to 99% for lead-acid batteries in the United States. According to experts, various materials can be recovered and repurposed from spent batteries. Batteries can be recycled in various ways, consuming large amounts of water or emitting harmful pollutants into the air. So that's all for today. So what do you guys think of this video? Please share your review of what you think of the video. Hope you liked this video. If you did, remember to like, share and subscribe to this video. Stay tuned as we will come up with many more entertaining educational videos. Till then, goodbye!